Hello friends, in previous two lectures we have discussed the types of continuous time signals, their operations, their functions. In today's lecture I will discuss the discrete time signals, their types, their operations. Okay, so now if I first consider the types of discrete time signals, then there are not many types as such in continuous time signals. There are only three basic types of signal we studied in discrete time signals. First is unit step, but do remember that we have discussed that every discrete time signal is a sampling version of continuous time signal. Okay, but remember that step signal in discrete time is not a sampled version of continuous time signal. It is a predefined function. So this is an exception. So you need to remember that step signal in discrete time is not a sampled version of step signal in continuous time. Okay, why we need to remember that? I will show you by this figure. Okay, step signal in discrete time is un. So if I draw that, it will be like this up to infinity, 0, 1, 2, 3 up to infinity. Okay, now amplitude will be 1, 1, 1. All amplitude will be 1. Now why I have told you that step signal in discrete time is not a sample version of continuous time step signal? Because if you remember the first lecture, I have told you that ut, step signal in continuous time domain, is a 1 by 2 at t is equal to 0. Okay, it will be the discontinuous at t is equal to 0, but not the case here. In this case, un at n is equal to 0 is 1, not 1 by 2. So un is 1 at each and every value of n. Okay, so this is the big difference, but similarity lies that un will be 0 before n less than 0 or before 0 values of n, same as ut. Okay, now if I consider the second signal, second basic signal in discrete time domain is delta n. Delta n is impulse function or Dirac delta function. It is again will be defined on n is equal to 0, and for other values of n it will be not defined, or you can say for other values of n it is 0. So how it is defined? It is delta n is equal to 1 for n is equal to 0, and it is 0 for n not equal to 0. Okay, now if I consider the third signal, which is your ramp signal. Ramp signals is also same as the continuous time ramp signal. Okay, if I define discrete time ramp signal, then it will be Rn, and at 0 it will be 0, at 1 it will be 1, at 2 it will be 2, and so on. Okay, so it again having the slope 1, because 0, 0, 1, 1, 2, 2. Okay, now if I want to define, then Rn is equal to n for n greater than equal to 0, and it is 0 for n less than 0. Now again, if I want to write only one equation instead of this two equation, then again I can define in terms of un. I can write n un. What un signifies? Un signifies that this n value or this signal is 0 before n less than 0. Okay, so again in discrete time domain also, what is the advantage of un? Un will make the signal positive sided. If you multiply any signal with un, the signal will make positive sided signal. Okay, now if I talk about the basic properties of these signals, mainly we have discussed the properties of impulse signal in continuous time domain. So they are absolutely same. Like here also, impulse signal is E1 signal. Here also multiplication property will be present. So xn into delta n minus n naught will be x of n naught into delta n minus n naught. The same integration property will become here the summation property, because in discrete domain we perform the summation. So sigma xn into del n minus n naught will become the x of n naught. Okay. Now if I take one example of n delta n, now what will be the answer? Here the multiplication property will be applied. So what is the multiplication property? If xn is multiplied with delta n, then answer will be x of n naught. What is n naught? N naught is the amount by which your delta n has been shifted. Okay. So x of n naught into delta n minus n naught. So here delta n is shifted by the 0. So you need to put 0 in xn. What is xn here? In this example, xn equal to n. So answer will again 0. The same question we have discussed in the continuous time signal, t into delta t. Okay. So absolutely same. So no need to take more examples, because it is same as continuous time signal. Just you need to put n in place of t. Okay. So these are the properties of impulse signal. Okay. Now if I want to perform the operations on the discrete time signals, again there are three operations. First operation is scaling operation. Second operation is time reversal, and third operation will be shifting operation. Okay. What is a in the first operation? A is constant here. Okay. If a is greater than 1, then there will be decimation, and if a less than 1, then there will be interpolation. Now these are new terms, decimation and interpolation. In continuous time domain, I have told you that if a is greater than 1, then there will be a compression, and if a less than 1, then there will be expansion. So in place of compression there comes decimation, in place of expansion there come interpolation. We will discuss when we discuss the example. Okay. Now what is x of minus n? Just you need to reverse. Plus values of n will become the minus values of n, and minus values of n will become the plus values of n. Same as continuous time domain operation. Now what is the shifting operation? If there is a plus sign, then shift will be left, and if there is a minus sign, then shift will be right. Okay. Same as continuous time operation. Okay. Now to understand this, if I take one example, then the process will be same as we have followed in the continuous time signal. Okay. Suppose I have take xn, and which is defined at n. So 0 I have taken 1 amplitude, at 1 I have taken also 1, at 2 I have taken 1, at 3 I have taken 1, and at 4 I have taken 1 by 2. Okay. So there are total 1, 2, 3, 4 and 5 samples. Okay. Now I want to perform different operation. Okay. So first operation I want to perform is x of n plus 3, suppose. Okay. Now if you remember in lecture 1 or 2, I have discussed you that there are three methods to perform these operation. Method 1 is just simply equate n plus 3 with all the values of the n present in the figure. But I have told you that we will not use this type of methods. We will directly use method 2 or method 3. Now we understand what is the method 2 and method 3. So directly you can use any of the method to get the answer. Suppose I want to use the method 2, which we have discussed in the continuous time signal. Okay. So what is the method 2? If anything with n, forget. Here with n there is a 1. So no change. And first we need to perform the shifting. Okay. But here with n scaling operation is 1. So no need to perform any scaling. If you look at this example, this is directly a shifting operation only. This example not contains any scaling operation. So directly there is a plus sign. If there is a plus sign, we need to shift left hand side by the amount of 3. So the answer will become xn plus 3. We need to shift by 3. So 0 sample will start at -3, then -2, then -1, then 0, and the last sample 1, 2, 3, 4 and 5, 1, 2, 3, 4, and the last sample will become 1 by 2. Okay, at -1. Okay, now if I take the amplitude 1, 1, 1, and the last amplitude will be 1 by 2, right? So this has been shifted by the -3 in the left hand side. Okay, now if I take next example, suppose I want to perform x of 3n plus 1. Okay, now example will remain the same. Example 1, 1, 1 and 1 by 2. This is my xn. Now I want to perform the x3n plus 1. So if I want to use the method number 2 again, as we have used in the continuous time signal, then forget anything with n. Here with n there is a 3. So first we want to perform, in technical term, if I say first we want to perform the shifting, then we want to perform the scaling. So first we want to perform x of n plus 1. Now if there is x of n plus 1, that means we want to shift by 1 in the left hand side. Okay, so 0 value will start at the -1 value. So -1, 0, 1, 2, and this is your 3. So 0, 1, 2, 3, 1, 1, 1, 1, and the amplitude will become 1 by 2, right? So we have performed the shifting operation. Now we want to perform the scaling operation. What is the scaling factor here? 3. So simple method, I have told you in the previous lectures, in the continuous time domain signal, same will be applied in the discrete time domain. You need to divide by the 3 the original xn plus 1 expression. Okay, so xn plus 1 figure is resides at n is equal to -1, n is equal to 0, n is equal to 1, n is equal to 2, and n is equal to 3. So you need to divide each and every value of n by 3. So -1 by 3, 0 by 3, 1 by 3, 2 by 3, and 3 by 3. Now, is this our correct answer? Because in continuous time domain, this is the answer. Okay, but in discrete time domain, if you look carefully, this is -1 by 3. This is 0. This is 1 by 3. This is 2 by 3, and this is 3 by 3. What is wrong here? The operation is correct, but remember the first lecture, I have told you that discrete time signal is defined only for integer values of time, not for point values of time. Okay, so here n should be integer. -1 by 3 is not integer, 1 by 3 is not integer, 2 by 3 is not integer. So the correct answer will be x 3n plus 1, and this will define only at 0, which is 1, and 3 by 3 will become 1, so it will define at 1, the amplitude will be 1 by 2. So there are only 2 samples will present, not 1, 2, 3, 4, 5 samples. You need to remember this thing, otherwise the answer will become wrong. Do remember, the first option in any examination will contain these 5 samples, but you need to remember that discrete time signal is only defined for integer values of time. So this is the correct answer. Okay, now if for the same question I take third operation, suppose I want to perform x of minus n minus 3. Okay, now my question xn again will remain the same, like this: 1, 1, 1, 1 and 1 by 2. Now I want to perform x of minus n minus 3. So again I will use the simply method 2. What is method 2? Forget anything with n. So here with n there is a minus sign, so I will forget and I will first perform the shifting operation, which is xn minus 3. So where it will be shifted? It will be shifted towards the right hand side because there is a minus sign. Okay, how much amount we need to shift? By 3. Okay, so 0 will start from the 3. So 3, 4, 5, 6 and 7. 1, 1, 1, 1 and 1 by 2. Now we have performed xn minus 3. Now we need to apply minus because we have forgotten the minus. So now we need to apply the minus. What is the minus? Minus operation is a time reversal operation. So this 3, 4, 5, 6, 7, which are the positive values, will become the negative values. You need to just flip these values. So your x of minus n minus 3 will become like this: 3, 4, 5, 6, 7, 1, 1, 1, 1, 1 by 2. But remember that this all are the minus values: minus 3, minus 4, minus 5, minus 6 and minus 7. So you will directly get the answer. Okay, now suppose if you want to understand the scaling operation, which I have told you, that decimation and interpolation concept. Okay, so for that, if I want to perform x of n by 2 and I will again take the same question of xn, now you will able to understand what is the decimation phenomena and what is the interpolation phenomena. Okay, so again I will take the 5 samples only to understand this decimation and interpolation phenomena. Suppose xn by 2 I want to perform, so n by 2, simply n by 2 will become 0. So n is equal to 0, n by 2 is equal to 1, so n is equal to 2, n by 2 is equal to 2, so n is equal to 4, and like this only. So just I have equated the n by 2 with each and every sample values of n. Okay, now if I draw x of n by 2, then it will be like this: my sample will be present at 0. Okay, but at 1 my sample is not present because after 0 there is a 2, then there is a 4, then there will be 6, there will be 8. So at 1 it is not present, so we need to mention, okay, 1, but it will be 0. At 2 it is again 1, but 3 it is not present, but we need to mention a point here: 3 it is 0, 4 it is again 1, 5 it is not present, at 6 it is again 1, 7 it is not present, and 8 it is 1 by 2. Okay, now if you see, if you compare these two figure, x of n and x of n by 2, you will see there are the samples are there from 0 to 4 only, but here the samples are 0 to 8. So my n range has been increased, so my signal, actually you can say your signal has been expanded. But in discrete domain, this term is called interpolation. So what is interpolation? If number of samples in the resultant signal is greater than the number of samples in the original signal, then this process is called interpolation. Okay, here in original signals my sample is from 0 to 4, but in the resultant signal my sample is from 0 to 8. So this process is called interpolation. Now what is the decimation? Now you can take x of 2n, then number of samples in the resultant signal will be less than the number of samples in the original signal, and this process is called decimation. Okay, so there are two processes, decimation and interpolation, with comparison to the continuous time domain, which are called the expansion and the compression. Okay, now one major thing, one important thing in discrete time domain, in any numerical in discrete time domain, they will not give you the figure. They will never give you the figure. Suppose your question is xn, the same question I will take 0, 1, 2, 3, 4, 1, 1, 1, 1, 1 by 2 and n. Okay, now if they ask you to perform several operations like x of 3n plus 1, x of 2n minus 3, x of n by 2, x of 4n, any operation, they will never give you this figure. So that how you perform the operation? So you should know that any discrete time signal is also represented like this. xn is equal to 1, 1, 1, 1 and 1 by 2. Okay, now if you see here, how we should know that this equation is equivalent to this figure? Suppose if you know the equation, how to draw the figure then? In this equation there will be a information that the where the n is 0, where the n is equal to 1, or where the n is negative. So always there will be a arrow sign. Arrow sign represents that here n is equal to 0. Okay, and this 1, 1, 1, 1 and 1 by 2 are the amplitudes. So n is equal to 0, 1. If you move to right hand side, n will increase. If you move to left hand side, then n will decrease. But here left hand side there is no sample, so right hand side if you move, because there are samples in the right hand side, this is n is equal to 1, n is equal to 2, n is equal to 3 and n is equal to 4. So you know that n is equal to 0, there is a 1, n is equal to 1, there is a 1. So you can simply draw the figure. Okay, but come to the last slide where we have studied the x of n by 2. If I come here, then how this signal will be defined? This x of n by 2, how we can define this signal? We can define like this: 0, at 0 we got 1, so 1, then 0, at 1 we got 0, at 2 we got 1, then 0, then again 1, then again 0, okay, then again 1, then 0, then 1 by 2. So n is equal to 0, 1, 2, 3, 4, 5, 6, 7 and 8. So this is a necessity actually. You should represent the sample n, because if it is 0, amplitude is 0, no problem, but you should indicate that at this amplitude, at this sample, amplitude is 0. Okay, so any discrete time signal contains the integer values of time, but these integer values are also continuous, that after 0 always 1 will come, that before 0 always minus 1 will come, after 99 always 100 will come. Amplitude may be 0 or anything, but you need to represent all things. Okay, so in examination always this bracket type of equation will given to you. Okay, never expect any figure in examination. Okay, now if I come to the next thing, the next question, suppose I will take one example. Suppose my question is xn is equal to 0 for n less than minus 4 and n greater than 3, and for other values of n my xn value is 5. Okay, so my question to you is, find out the values of n for which x of minus n plus 3 is guaranteed to be 0. We need to find out the values of n or range of n or limit of n for which x of minus n plus 3 is guaranteed to be 0. Now, if this is the example for you, now first of all you need to draw which is given to you. What is given to you? Xn is given to you. Xn is 0 for n less than minus 4 and n greater than 3. Remember, not less than equal to, less than, or not greater than equal to, greater than. So at minus 4 and at 3 it never be 0, it will be 5. So if I draw Xn, then Xn will be 5 at minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3. So it having the value of 5. Okay. Now we need to calculate x of minus n plus 3. If you draw x of minus n plus 3, then we can easily say the range of n for which x of minus n plus 3 is 0. So what is the method of drawing x of minus n plus 3? We know the method. Method number 2. First, forget anything which is with n. So with n we have minus sign. So we forget minus sign. We draw x of n plus 3. So first we draw x of n plus 3. What is the meaning of x of n plus 3? X of n plus 3 means my original signal will be shifted to the left hand side by the amount of 3. So my signal will become minus 7, minus 6, minus 5, minus 4, and up to, it will go up to 0. Okay, all amplitude will be 5. Okay, now if I want to draw now x of minus n plus 3, what I need to do? I just need to reverse, because with n there is a minus sign, and minus sign means there is a reverse operation. So this minus 7 will become the plus 7, minus 6 will become the plus 6, minus 5 will become the plus 5, and so on. So my x of minus n plus 3 signal now will be available from 0 to 7. So 0 to 7 it having the amplitude of 5, x of minus n plus 3. But before 0 n, for n greater than 7 it having the amplitude 0. Okay, so my answer will be n less than 0 and n greater than 7. Okay, so if you know the basic operation of shifting, scaling, then you can tackle this type of problem. Okay, now if I take another example, and if I told you that just draw this signal. Sometimes when we see the discrete time signals, then sometimes we have a hesitation that this is a simple problem or a difficult problem, but I will tell you by this example, this is a very simple problem. X of k is equal to 3 to infinity delta of n minus 1 minus k. Now if you want to draw this figure, okay, this is a long equation. Now how to draw this figure? There is a two terms here. One term is 1 and one term is delta terms in the summation form. Now just draw these two terms individually and just subtract them, because there is a minus sign here. So what is 1? 1 is a DC signal, na? In continuous time domain we have studied that 1 is a DC signal, but here it is a discrete time. It will be 1. 1 means from n is equal to minus infinity to plus infinity, the signal will be 1. But you need to draw in form of samples. This is the main things. Okay, so it will be go up to plus infinity, it will be go up to minus infinity. All values will be 1 1 1. Okay, at 0 1 2 3 4 minus 1 minus 2 minus 3 minus 4 up to minus infinity up to plus infinity. Right, now if I want to draw now delta of n minus 1 minus k, then this signal, how to draw? Very simple signal. Here summation is varies from 3 to infinity. Suppose k value is 3, then answer will be delta. What is the answer? Delta n minus 4. Okay, If k value is 4, answer will be delta n minus 5. Same n minus 6, n minus 7. So if for the positive values of k, because there are only positive values of k, so delta n minus 4, delta n minus 5, delta n minus 6, delta n minus 7, and so on. So you will get the impulses at 4, 5, 6, 7, 8, 9 up to infinity. All impulse value is 1, 1, 1. Okay. Now suppose you want to subtract, because there is a question, there is a minus sign. So if you subtract x, n, for that if you subtract 1 minus sigma k is equal to 3 to infinity delta n minus 1 minus k, then this two figure needs to be subtracted. Okay. If you see the first figure, this figure is minus infinite to plus infinite. All values are 1, 1, 1, 1, 1, 1. But here 4 to infinity values are 1, 1, 1, 1. So if you break the limit, suppose if you take minus infinite to 3 in the first figure, there is 1, but in the second figure minus infinite to 3 there is a 0. So all 1 minus 0, answer will be 1. But in both the figure from 4 to infinity there is a 1, and in second figure also there is a 1. So 1 minus 1, answer will be 0. So your xn will having the values from minus infinity to 3. You can simply draw your xn. This will having the values from minus infinity to n. N is 3. So this will be minus infinity 0, 1, 2, 3. 3 only. Okay. So this is your xn. So by this method, just simply put the values, just calculate the amplitude and each and every values of n. You can draw any discrete time signal, no problem in that. Okay. Now if I see the relation between the three basic signals we have studied, un, delta n, and Rn. These three basic signal we have studied in the discrete time signal. In the continuous time signal we have studied that they are integration of one each another and there are differentiation of each another. But in discrete time signals, instead of integration we perform the summation, and instead of differentiation we perform the subtraction. Okay. Now how to relate un, delta n, and Rn now? So suppose you want to say un is simply summation of delta n. You can write k is equal to minus infinite to n summation delta k. Like similarly ut is the integration, so un is the summation. Now what is Rn? Rn is simply summation of un. So you can write k is equal to minus infinite to n uk. Now what about the differentiation? Because here we need to perform the subtractions. Okay. Now suppose you want to represent un in terms of Rn or delta n in terms of un. Now how to represent? Suppose first I take delta n. I want to represent in terms of un. So clearly we know the indication, clearly we know that there will be a subtraction of uns. Now how to subtract un to un such that we get the delta n? So just first of all just draw the figure of un. You will get the idea. Un varies from n is equal to 0 to n is equal to infinite, and for all values of n the amplitude is 1. Okay. Now delta n is only exist at n is equal to 0. So we need to eliminate this n is equal to 1, n is equal to 2 up to n is equal to infinite amplitudes. How to eliminate? Which un I should take again? So this all values from 1 to infinite will be eliminated. Can I take u of n minus 1? If I take u of n minus 1, my signal of un will start from n is equal to 1, because it will be shifted to the right hand side by amount of 1. if I subtract this un and u of n minus 1, you can clearly see in the un at 0 we got 1, but un minus 1 at 0 we got 0. So 1 minus 0 answer will be 1, but from 1 to infinity in both the signals there is a 1. So 1 minus 1 answer will be 0. So you can clearly write that delta n is un minus u of n minus 1. This is your delta n. Okay. Now similarly, if I want to write Rn in terms of uns, how to write? First of all, Rn is just the summation of un. This is not a big task, but if I want to write un in terms of Rn, then this is a big task because there is a difference in between them. So how to take this difference? 2 Rn will be subtracted. So what are the values of these 2 Rn? First of all, just draw the simple Rn. Rn will be at 0 it is 0, at 1 it is 1, at 2 it is 2, at 3 it is 3, and so on up to infinity. Okay. Now we need to draw the un. How to draw this un? Because in un at each and every values of time, that is from 0 to infinity, amplitude is 1, but here amplitude is continuously increasing. So we need to maintain amplitude 1 at each and every value of time. So think at Rn at n is equal to 0 there is a 1, but un at n is equal to 0 there is a 1, but in Rn at n is equal to 0 there is a 0. Now if I take Rn plus 1, in Rn plus 1 at n is equal to 0 there will be a 1, at n is equal to 1 there will be a 2, at n is equal to 2 there will be a 3, and so on. Rn plus 1 is what? Just the left side shifting of Rn. Okay. Now if I subtract these two signals, Rn plus 1 minus Rn or Rn minus Rn plus 1, can we get un? Suppose if I subtract Rn plus 1 minus Rn, so Rn plus 1 at 0 you have value 1, but in Rn at 0 you have value 0. So 1 minus 0 answer will be 1. At 1 the value is 2 at Rn plus 1, but in Rn at 1 value is 1. So 2 minus 1 again 1. Similarly 3 minus 2 again 1. So if you subtract Rn plus 1 minus Rn, then you will get 1 1 1 1 up to infinity at each and every values of n. Okay. So un is nothing but the Rn plus 1 minus Rn. Okay. Now if I consider the next signal, suppose I want to perform xn is equal to 1 2 3 4 5 6 and there is n is equal to 0 at 3. Okay. Now if I want to draw this signal, we need to take also where n is equal to 0 is not at the first location. We need to see the example here. So xn is equal to 1 at which value of n? N is equal to 0 here. So minus 1 minus 2. So n is equal to minus 2 it is 1. N is equal to minus 1 it is 2. N is equal to 0 it is 3. N is equal to 1 it is 4 and 5 and 6. So you can also draw. There is not necessity that always n is equal to 0 will be at the first place. It can be in any place. Okay. So this is all about the discrete time signals. Now in the next lecture I will discuss about the types of signals, not about discrete and continuous time signal. I will take both the signals, but I will consider even and odd types, periodic and non-periodic types, random variable, deterministic types, and like this. Okay, so stay tuned with us. If you have any doubts, you can post in the comment section, or you can also mail us in the eiidelhi@gmail.com. Thank you. If you like this video, please share this.